What's up, everyone, and welcome back. Patrick here, moving on to another question dealing with factoring. This is more of a communication type of question, so we have to explain why it is easy to factor a quadratic ax squared plus bx plus c if a and c are prime numbers. So I'm going to show you this through actual examples using actual numbers. Now, the short answer to this before we get into detail is basically if a and c are prime numbers, then the part of the decomposition process where we have to find the two numbers that multiply to AC and add up to B, there's just going to be less options. You're not going to have to look through a bunch of different options when you're finding those two numbers. That's what's going to happen. So let me show you what I mean. Let's list out some prime numbers. Remember, what is a prime number? It's basically a number that only divides by itself or 1. And it has to be greater than 1. So prime numbers would be like 2, 3, 5, 7. The next would be 11, 13, etc., etc. Right? 2 can only divide by 1 or by 2 itself. 3 by 1 or itself. 5, 1 by or by itself. Right? It doesn't have any other factors. And so what happens is, let's say we have a quadratic. Let's just pick some random values for a and c from these prime numbers. Let's pick maybe the a value to be 3. Then let's just leave the b value as a general variable here. So we got 3x squared. So we got 3 for a, and then let's maybe use 7 for c. You could use any of these for a and c. I'm going to pick 3 and 7. So when we're factoring this, what's the process? Well, we have to find two numbers that multiply to AC. So we would multiply the 3 and the 7, which would give us 21, and then add up to whatever that B value is going to be. Well, notice that 21, which is 3 times 7, what are the different combinations of numbers that can multiply to 21? What are the different combinations of integers? Well, it could either be 1 times 21 or 3 times 7. And actually, because this is positive, technically it could be positive 1 times positive 21 or negative 1 times negative 21. So this could be plus or minus 1 plus or minus 21. And then same thing here. It could be 3 times 7 or negative 3 times negative 7, which would give us that positive 21. Right? And that's all of the combinations there. And so if a quadratic like this can factor, if we add these up, the B value can really only be either plus 1 plus 21, which would give us 22, or negative 1 plus negative 21, which would give us negative 22. So it could be plus or minus 22, or plus 3 plus 7 gives us positive 10, negative 3 plus negative 7 will give us minus 10. So it could be plus or minus 10, like that. Those are the only combinations for the B value in order for this to be able to factor, right? And the two numbers that go here, it can only be this combination. Now, let's say we had a different quadratic. Let's say instead of using prime numbers, let's maybe do like 4x squared plus bx plus, let's say, I don't know, 9. Right? So notice 4 and 9, those aren't prime numbers. And so notice that in this particular case, we're going to have to find two numbers that multiply to 4 times 9, which is 36, and then add up to that B value, whatever that B value would be. Now notice for 36, look how many different options there's going to be. There's going to be 1 and 36, right? 1 times 36, or plus and minus. These can be negative as well because we have a positive 36. That's one option. Notice it could be plus or minus 2, plus or minus 18. It could be plus or minus 3, plus or minus 12. It could be plus or minus 4, plus or minus 9. It could also be plus or minus 6, right? Plus or minus 6. So look at all the different options for these two numbers that we would have to test out, right? So that's why it's easier to factor when A and C are prime numbers, because there's just less options for these two numbers over here. Okay, and just in general, if we want to generalize this is always going to work for any prime number. So if we choose some other ones, let's say like 2 and, I don't know, we could choose maybe 2 and 11, right? Notice the AC value in this case would be 22. And notice for 22, the combinations that would multiply to 22 would either be plus or minus 1 plus or minus 22, or plus or minus 2 plus or minus 11, those two prime numbers that are over here, right? There's no other integers that multiply. So this is always going to hold. So if we want to generalize this, we could say that if we have ax squared plus bx plus c, and then we're finding two numbers that add up to the AC value, or multiply to the AC value, add up to the B value, it's either going to be those two values, A and C. These two numbers here are either going to be plus and minus A, plus and minus C, or plus or minus 1 and plus or minus AC. Right, where it's going to be 1 times that AC value. 1 times that AC value would give us AC, or negative 1 times negative AC would give us AC. Right, so it's always only going to be these combinations here if A and C are prime numbers. Right, so hopefully you got that. It's a little tough to explain. It's kind of tough to just give the answer in one sentence, but the short form is basically it's easier to factor if A and C are prime numbers because that B value is going to decompose into less options.